Transformations is another upper math concept. You were using shapes again and turning them, sliding them, flipping them in order to make these really cool patterns. Your younger child, your preschooler, your child who is still trying to get the dexterity in their fingers for cutting and drawing, this would be an excellent exercise for them to cut out pieces like this and arrange them in patterns. But it's actually a concept that they'll use in math calculations as they get older. So let's take a look at a few of them. Transformation means to change it, make it different. In this particular case, we've got a transformation called a dilation, where we take a figure, I use this big square, and make it smaller, proportionally. See how it's going from large to small? The enlargement of a shape takes it the other direction. Here we have the small star, and we're gradually making it larger and larger. Rotations are a turn, where we actually turn the shape. So starting out here, and this is a rotation on a point. So one of the points of the triangle gets shifted, rotated, and it looks like this in this position. If we take this and turn it again, if we give it a quarter turn, it looks like this, and another quarter turn this way. This rotation is going clockwise. If we look at it, it looks like a pinwheel. If you have a counterclockwise rotation, we're taking this shape and putting it backwards. If we pulled this down, it would look like this in this position. If we went backwards again, the top point would be facing to the right. If we made another quarter turn, a 90-degree turn, this would be facing upward. The pattern is going to be interesting to a young child, and the young child is going to have practice cutting and drawing to get those fine motor muscles coordinated in the hands. An older child is going to appreciate the clockwise and counterclockwise rotation of this turned on a point. We talked about symmetry before in a different video. That's where half of the item looks exactly like the other half. If we folded this over on this line, this section of the heart would cover up that section of the heart. There wouldn't be any funny things sticking out. It would just match it perfectly. That's called line symmetry. We have another line symmetry here where this figure just flipped right over. It just whoop, came off the board and turned itself straight around. We rotated these, but this one was a flip. And then it flipped again over this line to become this orientation and flipped again. Those are line rotations or line reflections, as if you had a mirror in these different spots or a mirror right here. Here's another example of a line reflection where this crescent flipped and then flipped again and again. Line reflections, point translations. Slide the figure here, square, slid up and to the right, slid up and to the right, slid up and to the right, slid down and to the right, down and to the right. So you can see how our original figure, this one square, repeated itself in a slide formation. In this case, the rhombus started here and slid to the next position. They make really, really nice patterns, and they're fun to do. Mathematically, you can figure out where exactly these patterns will occupy, the space it'll occupy on a coordinate plane. Drawing the cutting and the actual position of these for pattern's sake alone can be done as a great exercise for a younger child. The mathematical portion of this has formulas to follow, and I'll introduce those to you next.